Good morning, good afternoon, everybody. Welcome to our webinar on application security observability. Let me start with introducing today's speakers. It is my friend, my colleague, co-founder of Avocado and inventor of Avocado's application security observability, Chief Technology Officer, Keshav Kamble. And the second presenter is I, Joseph Feiman. I'm Chief Strategy Officer of Avocado. There is a good reason why we're looking at observability, and mostly because it seems to be very important, and yet it's hard to understand what observability is. We spent some time trying to find in from different sources the definition of observability, and that's what we are coming with. Gartner says that observability is the characteristic of software and systems that allow them to be understood based on their outputs and allow questions about their behavior to be answered. Maybe it's a nice definition. It's very unclear and it's obviously not actionable. There's another part that we discovered from Gartner that says that observability is the evolution of monitoring into a process that offers insight into digital business application. At least here, we start understanding that observability and monitoring are somewhat related, would give us some food for thoughts. We found a good example of a definition from open source project called DORA, DevOps Research and Assessment. And what they say is here actually interesting. They say monitoring. Monitoring is based on gathering predefined sets of metrics, while observability, they say, is based on exploring properties and patterns not defined in advance. So using definition, these two and others, we're coming to understanding that observability is somewhat like monitoring and yet somewhat different, and it's not exactly clear how and why it is different. So we use our pragmatic approach to understand what it is. And that's where we're coming from, going from the name that means somewhat little into actions. These are three definitions, three actionable characteristics that we believe are critically important for observability that make it really different and important. First of all, observability should allow you a view from inside of the application out, from system out, but from inside. So you can see and capture everything, processes, sub-processes, API calls, execution of instructions, something that when you look outside in, you cannot capture. That makes a good difference. There is another criterion or characteristic. It should be in-depth diagnosis versus on-the-surface diagnosis. We'll talk in half a minute about technologies that can really touch the surface, that probe the surface of an application and do a good job, have been doing a good job for 15 years, but they don't give insight, in-depth picture. And the third characteristic is understanding of unknown patterns, understanding anomalies and deviation, not just known patterns. You know, the most difficult to detect attacks are so-called zero-day attacks, when by definition you don't know patterns. So if you don't know patterns, how would you monitor them? How would you observe them? So this is the third requirement, to understand anomalies and deviation. So this summary, the view from the inside out, view in depth, not just scratching the surface, and understanding more than known patterns, understanding unknown patterns. That's what we put in observability, in security observability specifically. There is another thing related to this view from inside out. How would you view from the within? Well, there is a thing called instrumentation. If you look outside in, you're speaking of technologies such as DAST, you're familiar with dynamic application security testing, or web application firewall, WAF. You know these technologies, they're a good example of look from the outside in. Dynamic application security testing for a good reason or for a bad reason. It's called a black box technology. It can sense sometimes vulnerabilities, but it cannot understand where in the application they originate, what's happening inside the application. That's why we're facing inaccuracy of detection. Web application firewall, same. It watches applications submitting stream of data. It captures this data. It tries to parse them and tries to guess what's happening inside the application. But it has no way to look inside. These are outside in views. We should be looking here if we want to get observability or not, but in the new wave of observability, monitoring, and security, we should look inside out. And there are technologies that do this. There are agent-based technologies such as REST and IS. When you incorporate, typically it's dynamically in runtime, you attach an agent that has insight into the application. And another way is using system plugin technology such as Avocado does. When you're attaching at runtime this plugin, also kind of a degree of an agent, but that watches some different things such as API calls. These are instrumentation technologies. And there is some concern about instrumentation. Will they affect me or not? But same DORA research says, if you want to have this monitoring and observability, your system must be instrumented. This is a quote. That is, code must be added to a system in order to expose its inner state. Later on, we'll talk whether you really need to write something or someone like Avocado in that case, or REST technology will do it for you. But point is, if you want to have the view from the outside in, you have to instrument that system. So let us see the difference. We agree that instrumentation is absolutely necessary. And let us see the difference between agent and plugin. Both are very powerful technology. Let's just see the difference. We're not recommending one versus another. The agent, what agent strengths are, its observability inside the application. It actually observes the execution of the code, conducts analysis, and can come to a conclusion whether it's a potential vulnerability, potential exploit, and then alarm you and stop further execution. It has challenges, a few of them. First of all, it makes somewhat substantial impact on performance because the CPU that executes that agent is the same CPU that executes the application itself. So it's eating part of CPU cycles. Then this technology is language dependent. It means that you have to create one agent for, let's say, Java, another one for .NET, another one for PHP, for Python, and so on. Well, it's somewhat not very easy to do, although it could not overcome. And that it is primarily internally focused on the code executed by the application, somewhat lacking insight into the process level onto API calls that go in between instances such as microservices and across the ecosystem. Nevertheless, it's a very powerful technology that does give you insight from the within. Plugin, its strength, its observability inside application peripheral processes. It sits on top of API calls, if you wish, a more simplistic picture, and Keshav will get into details. It captures API, it sees all of them, they cannot escape its attention and see them inside the application or across the ecosystem. Then technology is language agnostic. It doesn't care whether it's Ada or Python language used for writing application. You don't need to instrument the language VM like a JVM. It's platform agnostic. It works on modern application or legacy application or monolithic application or microservice. The same plugin works there. And the impact performance is unnoticeable because it's adding a tiny overload, not to the code execution, but to the submission of an API. It does have its challenges, of course, unlike agent. it doesn't have insight into internal code execution. So we're not choosing one versus another for one purpose, like API security. You would probably choose plugin. For logic flaw definition, detection, and protection, you might use agent. You can use both of them. We're just showing you that, number one, instrumentation is necessary, and there are two ways to our knowledge, agent and plugin, that assure it. Now, so we're done with inside out. We see the advantages of inside out. Now, on the surface versus in depth. And the typical example of on the surface, scratching surface, is the architecture, the way we're using it. That's how I'm saying all organizations start developing and then maintaining their application. They're using diagramming tools. They're using threat modeling tools to draw a diagram. Then they build application and assume that that's what they have. That is absolutely not true. I believe Keshav will show you, or even I show you. There is another way, seeing not architecture, but vulnerability for security specialists. And once again, you see vulnerabilities, list of vulnerabilities, but they're typically coming from these technologies that are black box technologies, such as DES technology, dynamic application security testing, or web application firewalls that have no insight into the application. The real in-depth insight, it would be from technology that do instrumentation. I'm showing simply an example of Avocado because it's our own technology. And here you see every block captured at runtime. And every block is, here is the browser that launches attack on Java application. Here's Java application that's reaching out to NoSQL database. There is a microservice 1 and microservice 2 that are reaching out to applications. So you have a complete architecture, you have a complete attack surface, complete vulnerability surface. All assets detected, and here on the right-hand side, it is also a list and explanation and diagnosed security vulnerabilities such as remote code execution or cross-site scripting. That's what I would call in-depth observability. And the last thing, briefly, known pattern versus unknown patterns. I tried my best to show, it's hard to show them, but here's the application one, and we can capture API call from the user interface to business logic. Then we see call from business logic to database. We see this application one is calling application two. We see that application two is calling an application three. And you can wonder, and you can use even patterns, but there are situations when patterns are not applicable. What I try to show is that here is the deviation from normality. And good observability technology must be capable to understand normality versus abnormality and deviation. I showed it graphically, but in reality, the abnormality could be a different payload. A payload as a script instead of payload as a text. It could be text in clear, not protected. It could be different origin of the call. It could be different destination of the call. Nevertheless, the ability to see the deviation is what would make a good observability technology. So let me summarize our actionable definition of observability. What in reality in action it should be. Observability is a set of capabilities that enable understanding of an application through following features, and these features are, all three of them are a must. The first one is viewing application from inside out, and instrumentation is the must. It should be something that sits within the application. Not necessarily you should modify the code. Keshav will talk about that. But instrumentation, per the definition of this open source project, is a must. To do inside-out view, we should be able to look in depth, not scratch the surface. So it's not just detecting applications, it's seeing processes, sub-processes, API calls, database calls. With all these parameters, that's what required of observability in a practical sense. Detecting unknown pattern in addition to known patterns, which means that we have to be detecting anomalies and deviations. And that is really very difficult. This observability should be persistent, meaning it should be always active and endlessly monitoring, watching, observing, never leaving application and API ecosystem unattended. In other words, it should be monitored, not a scanner. DAST, for example, cannot be, or SAST cannot be those real observability technology. And it should be working in runtime. Only a running application, running a dev part, pre-deployment and off part, can be observability. All the runtime characteristics become actionable and therefore observable. With that, I'll pass for greater deal of details, screen and microphone to Keshav. Keshav, please.
Thank you, Joseph. Quite interesting thought process here. And especially you have done a great job in comparing the definition of observability. You see, what happens is, in my experiences, when someone says observability, it is always subject to interpretation. There is certain amount of ambiguity amongst the security professionals about what exactly the observability is. So let me add a little bit more fun to the definition of the observability on top of what you have already defined comprehensively. Now, obviously, you have said it's an extension of monitoring, obviously. Uh, so, in my mind, this observability, and I'm going to be very specific to security observability. Okay. And I will explain you why I'm focusing on the security observability component. So, in my mind, observability for security is a combination of monitoring and advanced telemetry that enables you to monitor, collect, visualize, analyze, and draw actionable insights with respect to security of the application ecosystem. You see, most of the times in the industry, when someone says observability, they're always focused on the performance and bottleneck part of the application ecosystem. So there are many vendors for observability. Basically, application performance management is one of the observability solutions, but it is focused on the performance of the application. If it's a complex three-tier application, how the APIs are ingressing into the system, where they are getting served, where is the application tier, where is the database tier, and where is the bottleneck, or where exactly the instructions are taking longer than expected. Now, some of these insights, they do help in terms of scalability of the application, especially for performance. Now, the biggest component these application performance managers lack is understanding of security. You see, performance is one thing, but security is completely different thing. So our focus, or I would emphasize on observability for security. That means your ability to collect data, metadata, your ability to understand that data and the details that you collect, they would be giving you more insights into the security and vulnerabilities of your ecosystem. So therefore, you can imagine application ecosystems are complex, no doubt about it. Enterprises, they actually, one of the biggest issues they have is their business applications are very complex. Obviously, they perform complex business logistics for them. However, an approach which can actually work with such complex application ecosystem and provide you that security observability needs to be defined properly in terms of attributes. So in my mind, one of the biggest um, component of observability is high fidelity or high precision, which means even if you are a plugin based like the Avocado, or an agent based like RASP solutions out there, one has to have ability to collect, or one has to have ability to reach to the lowest level and collect extremely high fidelity, high precision information, data and metadata about the runtime ecosystem of your applications. Which means in the runtime, your application is more vulnerable, unfortunately, is more susceptible, and it exposes multiple vulnerabilities. So uh, having that ability to collect detailed, precise data is one important attribute of observability. Now, second component obviously is, since you're working in runtime and large number of applications in runtime, they are highly scalable, they are high performing, including the likes of microservices. So the the observability solution has to have real time consistent streaming information attributes, which means when the events are occurring in runtime, let's say APIs are being called inside the application ecosystem, you have to have a real time understanding of what exact APIs are called, why are they called, what are the data accessed, what business logic is triggered, etc., etc. So the real time nature of it is important. Therefore, by having a real time nature, you have ability to respond in near real time. Now, the third attribute is high analytical value. So when you collect this information, your security observability, when it is collecting this information, you should not waste your time in collecting esoteric, irrelevant information. One of the biggest factor in tuning the many of the data-driven artificial intelligence systems or neural network-driven systems is the value of analytics, or the value of the data in terms of analytical value. So data which adds more analytical value, which gives more insights, is what you want to collect, because you're doing it in real time. You need to precisely collect the data of high value and not waste your time in collecting something of a no value. Now the fourth component is very, very important. It does not matter which application architecture you have, as Joseph talked about monolithic legacy architectures, or even the latest microservices, event driven architectures, API driven architectures. Scale is important. The scale would basically mean you're performing line rate, you're scaling at line rate with the application scale, which means you have that elasticity built into you. So when you have the security observability technologies, it has to have ability to sit with the application, perform with the application, and scale accordingly. Especially the microservices and the Kubernetes clusters, they scale tremendously into thousands and sometimes even multiple thousands of instances in runtime based on the load. Now, there are hardly any monitoring technologies available which has ability to scale to that extent. Now, although it is unfair to expect, however, it is necessary. If you want to be a precise application security observability solution, scalability is an important aspect. Now, other part of the scalability obviously is non-blocking nature. What happens is many times, especially the monitoring technologies, unfortunately, they create head of line blocking, because they have to collect data and send it out to process somewhere else. Now, that adds head of line blocking, which may add performance bottlenecks into the applications. So it is paramount that the security observability technology should be non-blocking. Whatever information it is collecting, it can collect, it can process. However, it should have no or least impact on the applications. And those are some of the 5 attributes. I'm sure there are lots of other attributes that audiences can think of based on their application ecosystems, but these are the 5 for now to highlight. Now, let us look into something that Joseph just showed you a few minutes ago: architecture and vulnerability observability. This is one of the most favorite slide of mine. As a matter of fact, this output came from Avocado Security Orchestrator. It has the Avocado Reveal as the observability technology for security. Now, out of all observability technologies, what is most important is having ability to build your runtime architecture. Right. So, and we can debate all. And Joseph is a ferocious debater on this one. Theoretical architecture versus runtime architecture. There is a huge difference, obviously, and we agree to all of that. Now, having a runtime architecture which looks very very different than your theoretical architecture, how do you really understand, number one, the architecture fan out, number two, the dependencies through the APIs or the data access dependencies? Building such a precise picture is the primary motive. As you can see here, a complex ecosystem, application ecosystem, when it was seen through the security observability, it created a very complex picture with precise listing of every architecture module that came into execution, vulnerabilities associated to each of it, color coding as to red, green, orange, and then their dependencies with each other as well as external dependencies. Now, this particular picture is a aha moment for many of the application architects and security architects, especially, right? Because it gives you some of the things that we talked about, like unknowns. Knowing the unknowns is very important in terms of application security or designing application security architectures. Now, listing precise vulnerabilities is yet another advantage, not just seeing a connection of circles with each other, but having a precise listing of vulnerabilities on each of those, precise listing of the APIs which connect these modules together, as well as the external clients to the applications. Now, to this, I would call the first step in the architecture and security observability. Now, having said that, let me run through some of the funny things. In all of our lives, we have been application architects, we have designed many applications, we have seen many complex applications. One thing all of us do in common is when you're drawing an application architecture, all the databases are shown as a cylinder. Just go randomly check any application architecture. When it comes to database, there is a cylinder. Now, we were worrying about this cylinder for a very long time, especially if it is a cylinder that says Oracle Rack. Now, Oracle Rack, all of you guys who are Oracle database administrators and security guys out there, you're very well aware that that cylinder doesn't mean one single block. It means hundreds and thousands of individual components. And that is exactly what we did here. So after deploying Avocado Reveal Observability for Oracle Rack, this is what emerged. And you can see that this particular single node rack, it's like just one single node rack, has roughly about more than 40 plus processes inside it, various monitoring mechanisms, various handshakes, various heartbeats. You know, it is amazing that all of these databases, they have different levels of internal architectures, different levels of messaging systems, different levels of especially sharing the data for instructions for SQL as well as for NoSQL, depending on that. They have internal heartbeats, they have internal monitoring mechanisms, they have internal failover mechanisms. Now, they are a lot bigger than the actual core functionality because they have to be highly available. Unfortunately, many of these components, they are exposed to their own vulnerabilities as well as external attacks. So by looking at this particular picture, which is a real picture of an Oracle Rack single node database, you can imagine how vulnerable this database can be, because number one, it is talking to external world, just like although it is not talking to internet, but it is still talking to other application ecosystems around, transacting messages, solving queries, etc. But at the same time, you can understand the vulnerabilities or threat surface associated to the database. If you have multi-node rack, that means your vulnerabilities are multiplying exponentially. To an extent, we have seen roughly about 200 some processes associated to a multi-node rack, Oracle rack database. So all the more reasons that you should be much more careful about the application security observability, and especially the application architecture components which are abstractly represented in your architecture, because quite often than none, the vulnerabilities associated to those abstract architectural elements would be quite bigger than you can imagine. Okay. Now, what are other use cases of this? You're collecting tremendous amount of data, metadata in runtime from the runtime application. This is regarding the application as well as the surrounding ecosystem. One such application of all the metadata and metadata through the security observability is to build your application runtime threat models. Architects, they are supposed to build these application threat models early in the design, but you can see early in the design you have only so much information about the details. Now, building a precise threat model isn't a joke. It takes roughly about 3 to 6 months for a complex application, and tremendous number of engineering and architectural resources. Automating such a thing is complex. However, you can see here the whole application security observability. One of the output that it gave you is a runtime threat model ready to be consumed in your one of the favorite threat modeling tool called Threat Dragon, the OWASP Threat Dragon. All the data that comes out of the application security observability in the JSON form or HTML form or CSV form, various forms of the output, you can build your threat model readily without a single change in the JSON file. You can see the power, you can see the complex connectivity of each module and the vulnerabilities details in each of it. And you can do it continuously. You don't have to do it only once in a while. You can literally do it every day. And you can see what happens every day in my application architecture. And that is where we come up with second use case, application architecture governance. Now, quite a mouthful, but idea is very simple. Every release after release, you're adding or deleting some code out of your application ecosystems or some components out of the application architecture. Now, on day one, when you run your application, it gives you one application architecture model. On day five, when you run the same application and see what's happening with my application, you would have another set of observability architecture diagrams. These are very easy to build. They come ready-made from this security observability solution. Now you can compare these two. You see, on day X, I had my ecosystem running fine and performing some task for me. On day Y, the same application ecosystem with a different release was doing some additional work. Now I want to know what exactly had changed during that Y minus X times. And I had a API 3 that is listed here. That API 3 was talking to databases. So it had an additional API or overloaded API to interact with databases and perform some additional tasks. It points me precisely what was the difference. As a security architect, am I worried? I'm not actually worried, but it tells me something really, really important, much more informative for me to understand that application architecture is evolving, growing more and more complex. And therefore, I can, as a security architect, I can be even more precise in terms of designing my security around the databases or around the micro application ecosystems or even the API gateways for that matter. That's the beauty of it. So, application architecture governance is an important aspect of any CIOs and any CISOs out there, right? And I believe with that, I would come to my last slide. It's more of a conclusion. So, I'm recapping what we just discussed. So I would focus more on the avocado approach, obviously, because we designed this approach after studying almost for about a year and a half, uh, just studying, looking at things, looking at the requirements. So securing application APIs in the cloud or multi-cloud environment. One thing that is necessary is it has to be always active. Runtime activities, nobody can stop those. If you miss one, you lost that activity. So being always active is important. So you have understanding and control over every event that is occurring out there. Runtime observability, obviously in runtime, the importance of runtime versus static analysis is quite different. So in static analysis, you have certain access to the code, or you have certain access to various components of the code, and you perform your analysis offline. You can catch vulnerabilities, definitely. However, in runtime, there are life is life adds very complex metrics into the application. It has its own runtime, it has its own environment to run in, it has its own surrounding to, and it has its own exposure as well. All of that makes it important that we do it a runtime observability. And it is quite an addition into your existing portfolios, obviously. Now, application architecture are continuously evolving. What used to be legacy monolithic applications running on bare metal servers now uh, later became virtual machine based, VM based, more elastic, and then became containerized Kubernetes cluster based, and then now event driven, API driven architectures based on various application clusters. Cloud, multi cloud environments, these are adding yet another dimension to it. So at the end of the day, these applications and APIs, or the application processes, sub processes, and the APIs are the DNAs of your application ecosystem. You got to understand them better, build the architecture for those in runtime, understand vulnerabilities in each of those. Very important for security architects. And obviously, developers or development architects would benefit from it tremendously, because looking at your own architecture in runtime or looking at your own design in runtime, it's a very different pride for application guys. Now, something very interesting that especially Joseph keeps talking about is legacy programming languages versus the newer languages, more like a Java, Python, obviously, RR, etc. Unfortunately, many of these monitoring agents, they have very language dependence. Every language, they have different probe, different agent, different ways of doing things. However, we pride in having a completely programming language agnostic, architecture agnostic observability. It doesn't matter if you have Ada, and you can go Google about it. Ada was a very Jurassic era programming language. Many of the embedded systems early on were programmed using Ada. However, it is important that doesn't matter how old system is, even if it is written in Ada or written in the most modern language, plugins or the observability is important to those, and it should work. Be it legacy or modern architecture, be it monolithic or microservices, very important. And the last point is autonomous AI powered. You see, most of the systems, they collect information, They take it out, put it somewhere else, run AI systems, engines on those, which are pre-trained. Now, some of the important things that both Joseph and I agree on is you have to have highly scaled out distributed AI systems. You cannot afford to train a system because there is no perfect training of a system. There is always ambiguity, right? And me coming from IBM gives me some credibility to say that because I know how Watson works. So there is no data, no amount of data can precise an AI system. However, an approach to a highly scaled out distributed approach to AI using threat surface reduction. Again, some of these are mathematical terms, complex to digest right now, but in simple terms, an AI powered system with highly scaled out distributed AI is important for precision and real time responses. And with that, I will hand it over to Joseph, and I hope you're enjoying the conversation.
As to me, I've heard you saying that many times, and once again, I enjoyed that conversation. We have what, 3 minutes, a little less, two questions maximum. I have one that is directly asked. Uh, can I read it? And then we'll read one of yours. The next one, it will be yours. That's what it says. Joseph, you quoted, Joseph, you quoted that observability requires instrumentation, which in its turn require adding code. Who should add this code? Should my developers write that code? A very legitimate question. Honestly, I'm concerned about that definition that leaves this issue open. From the practical viewpoint, I can tell you that technologies like Avocado, which is plugin based, as well as technology that are agent based, they do not require you to write any code. Their technologies are, if you wish, interceptors at the places where observability is required. They plug themselves in real time, absolutely seamlessly, without requiring to change any line of the code. They collect information and they take action. So if you want to go with one of these agent-based or plugin-based like us technologies, you would not be required to write any single line of the code. That is my quick question. Go ahead with it. We have 2 more minutes.
I
Keshav.
I think there is some question here. Hold on, okay. The question is, it's basically you talked about observability of unknowns. Can this solution look into zero-day vulnerabilities like Log4j?
You answer.
Yes, so the obviously the zero-day vulnerabilities or the observability of unknowns. Again, it's kind of a catchy word, but yes, security observability like the Avocado, it does have ability to understand and intercept Log4j type of exploits. So the application, when it is penetrated through certain patterns, and then it falls victim to that attack or penetration, and then it acts on that. It basically falls victim to that penetration. Those the pattern, ingress attack, and the exploit that happens, and the effect of the exploit, they are all observable through the Avocado security observability. As a matter of fact, even if you do not know the pattern of the penetration, you can still observe the effect of that particular attack and what exactly transpires out of it. So yes, and Log4j especially, it was unfortunately large amount of ecosystems were exposed to for a very long time, and it was paramount that understanding of those zero-day vulnerabilities, not just Log4j, but many others, which converts into remote code execution or even giving out control of your ecosystem to the command and control centers outside. All those vulnerabilities, they are completely observable, and you can see them in detail.
I just want to add, guys watching this webinar, we had a webinar that was broadcasted in July. There, we specifically show you real-life demo of how Avocado detects and alarms, and then if you want, stops off for geotech. With this, we are 1 minute past the time. I want to thank everyone who was on this call. You will be able to watch this on BrightTalk platform, and also today or tomorrow we'll place it on YouTube along with our other webinars. We're planning another webinar in about months in the beginning of November. I hope we'll see you there once again. Thank you very much for your time.
Thank you very much. And for more details, please visit www.avocadosys.com/reveal. Enjoy the rest of your day.
Goodbye.